this is 2x plus 1, okay? What's a point that's definitely on this? Like, let's go with 0 minus 1 is definitely on this. So that would be the point that you would start from. You'd start from a point you know is on it. So this is now the derivative. And let's say we did not know this. We did not know this. All we knew was the derivative of the function is this, and we know that this point is on the function at some stage. So how do we get what the function would look like? We can use a bunch. Now this is an easier example, but if it's a more difficult equation.
That's why it's something you can't integrate, or it takes too long to integrate? Is that why
Or you don't have enough, it's more about the C. More, you don't have full information for the C part. Yeah, but yeah, so instead of integrating, we're going to say, right, we're going to start off at 0 minus 1, because I know it's on 0 minus 1 is here. We're going to start off here, and then we're going to take a little iteration beyond that. Now you can jump up in ones, but it's not going to be very accurate. We're going to if you jump up in 0.1s, it's going to be more accurate. And if you jump up in 0.01s, it's going to be even more accurate. And it's just going to be loads of little adjustments of the tangent until you figure out that the tangent is actually leading you to where the function would be and giving you an estimation for where it would be at a certain point. And that's what Euler's method is about. A little using the tangent to the function to figure out where it's going by little by little. And the littler the steps you do in Euler's method, which you haven't seen yet, the littler the steps you do, the more accurate it becomes, because it'll adjust a little bit better every time.
So it will look like this. It will look like that.
Yeah, it will look like that, because we just did an example there. So when x is, let's say we say, right, we know that this is 0 minus 1, so the next point we could take is a little bit beyond 0. And then we can add on to the minus 1 where our next spot is going to be. Because we're starting at minus 1, we know it's going to be minus, or maybe it'd be minus 0.8 or something after that, depending on the jump we do. Let's look at an example, because I'm making this up on the spot, and it's a little bit, what's the word? It's a little bit simplistic, yeah. So let's look at an example. So we have one on the next screen, hopefully. Okay, so this is very typical exam style question. So we've got a differential equation here, e to the x plus 1, and we're given this. Okay, that's definitely on the original graph. You see that? And they've asked us to estimate with Euler's method. Let's call it EM. Okay, and then they've given you a couple of ways they're going to do it in jumps of 0.25 and then jumps of 0.1. So, so there's two questions for 2 steps, and part 2 is h is 0 for 5 steps. So using what I said, we're going to get to 0.5 on the x-axis, either 2 jumps of 0.25 or 5 jumps of 0.1 to get to 0.5. And we're going to estimate what the value is going to be there of the original function. See that? So the value at 0 is 1 of this function. We only have its derivative. So what do? That means we can get the tangent. So we set up this. You might see one of these tables. You won't have to draw one. So I'll just we see these headings to get used to them. X n minus 1, y n minus 1. The derivative then at that point, x n, and then y n. Okay. So n minus 1 is like the stage before we start to go. So that's going to be this initial 0 for x and 1 for y. Okay, that's our starting point. And then we're going to use the derivative to find the next point. And then we're going to start again. Okay? So this is when our steps is, I haven't probably drawn this, our steps is 0.25. So 0.25 are our steps. So this is the first step. Okay, so yeah, what's the slope of the function of the tangent to the function at 0?
1, not 2.
So I'd sub in 0 into here. I get e to the power 0 plus 1, which is 1 plus 1, which is 2. The gradient's 2.
Is this the method?
Victor, what are you doing? What is it?
Okay. So what is the? Yep. This dy over dx. Yeah. So that's the gradient at 0 is 2. Now how do I use the fact that the gradient at 0 is 2 to figure out what the function is going to look like at 0.25? We moved on a little bit. What will y be at 0.25? So the x value has gone up, it's like we're trying to build up the function. We're gone from 0 to 0.25. We know it's 0, 1, but what's the y value at 0?
Y minus y1 equals.
There's a quick way probably. We know the gradient. We know the gradient is 2. But that's a gradient 2 if the x jump was 1. It's a gradient 2 over 1. So what would be the
Half?
the jump? Half?
2. Because it's
It'd be, yeah.
a quarter x2 minus 1.
It's like the starting position. The starting.
Oh, yeah. 0 x, y, 1.
Okay, it's sort of like our start position, yeah. Before we've started. Yeah, we have to do this twice. We have to do this twice. Yeah, you're right. This is only going to get the first step. So why did we get an answer of 0.5? It's moved on 0.5 because it's a quarter of whatever the gradient's saying. It was only going to move a quarter that distance, if you will. So that's where we'll take our next reading from. We're going to follow this tangent not for the full length of 1 over 2. We're only going to go to a quarter of that. So a quarter of 2 is 0.5, which means now the y has moved on to 1.5. It's moved on from 1. Remember the first point here is 0, 1. Now it's 0.25, 1.5. So it's moved on a bit. And then we're going to recalibrate, and we're going to have a little look again. So now our new points are 0.25, 1.5. Now we need to figure out what the gradient is at this new point. We moved on a bit. We moved on 0.25. So into the original, yes. So what's now the new gradient at 0.25, and then we're going to adjust again. So e to the power of 0.25 calculator time. I'll do it. You can put in your calculator. You should get 2. Yes, we're moving.
1.284.
Well, plus 1 because that's the gradient.
Plus 1? Oh, yes.
Yes. So e is 1.284. 2.284. Yeah. Very good.
And so the new x is
Okay.
0.25 plus that.
So we know the next coordinate, x coordinate, we know is jumping up in 0.25. So we don't know the next y coordinate. If we remember, how do we find it in the first place?
Y minus 1 plus the gradient. Is that how that works?
Okay. So we got 0.5 here, and that was added to the 1. So what do I add to the 1.5?
Is it a half of 2.24?
2.64?
0.5 times 2.84 plus 1.5.
Because that's the new gradient.
That's a new gradient. You fit
The new
easier.
gradient.
Is it right?
Well, I don't know what you said. It's 2 point something. 2 point, what did I get? 2.648.
2.648.
2.648. How do we get that? How do we get that? People are lost. How do I get that?
Multiply 0.5 by 2.28, then add that up to
1.5?
1.5.
Okay, let me just check to see if that's
2.648 really an
correct.
estimation? It's like low-key just solving the question.
No, it's not. It's an estimation because we never actually found. We're just using the.
I wonder how close it is to the actual
Is that
function
the
when you
answer?
iterate it.
No, it's not. It's 2 point.
642?
Oh, sorry. You've done the next one. Sorry, you made the same mistake that I thought you'd make. I wrote down the wrong answer and the right answer. The right answer is 2.07.
What?
This is wrong.
Oh, you found it all.
It's yeah. It's a quarter.
Then why did you write down 0.5?
You wrote it, and then I hadn't checked the answer.
Oh, it's the difference in the
Yeah.
I did that before. And
Yeah.
Shut up.
Sorry, Sean.
So it's a quarter again. We're moving up in quarter steps.
I wasn't crazy when
A
I did
quarter
that first.
step.
Because we're going from 0.25.
Moving up in a quarter step, yeah.
2.7.
So we're not moving up. That is not, the jump from here to here is a quarter. So we're moving a quarter step each time.
Oh, just multiplied by 0.25 again instead of 0.5.
So what are we multiplying 0.25? Well, okay, let's go back. Let's go back. How did we get this? I think it was easier with the first example.
So
We
0.25.
0.25 by 2 gave us this jump of 0.5. So if I multiply 0.25 by this is our new gradient, which is slightly more. I should get, I've removed the answer. What two numbers add up to give this? So you're multiplying 0.25 times 2.284, which is our gradient, which gives us what the next jump is going to be. And then,
the original y.
and plus your 1.5 gets us to the next step. So we add it to this to get the next step on y. Next step on x, next step on y. And that gave the 2.07. And we stopped because that's it done.
Is there a formula for that? It's the h times the gradient plus y and minus 1.
Now there's definitely something quicker way to do this on a calculator, which I'm going to show you in a second. But sometimes I've seen, well, not really, but more in book questions, I've seen the table where you have to fill in the table. Let's just do one more step. So we've answered the question. So we've gone up to 0.5. And this is our answer for 0.5.